Okay, in this video, we are going to take our simple example a little bit further. You remember that we were working on this very simple example where, uh, let me increase the size of the fonts and run this. Then you will remember where we have um, a reservoir, a long pipeline, and a demand point. The demand here is fixed 40 liters per second, and the pressure is calculated like this. Now, the next step I'm going to do is to make this demand a little bit more realistic because consumers don't use water in equal amounts throughout the day. So if you look at a whole day of use, you can see variations. So that's what I'm going to look at now. So go to the browser and data and select patterns. So we are going to create a demand pattern. So click on this add button here. So here is our demand pattern. Let's say PET1 is the name. Say assumed consumer demand pattern. Now what you need to do is for the 24-hour period like this, you have to specify uh, the multipliers. So how you calculate the demand at a given time is by multiplying the average demand, in this case 40 liters per second, by this multiplier. So for example, at 1 o'clock in the morning, maybe people use very little water. At 2 o'clock, maybe a little bit more, I don't know. So like this. So you can complete this 24-hour period, making sure that the average of the multiplier should be 1. That is very important to make sure that uh, we are specifying a valid demand pattern. Now, in order not to use a lot of time, what I'm going to do is I have saved a demand pattern, so I'm going to load it here like this, but you can type these things in. So as you can see, the average demand is 1, and you can see there is a peak demand around 6 or 7 o'clock, and then another peak in the afternoon. So that's very normal in many water distribution systems. So that replace all references to pattern 1 with pattern pet1 because we change the name. Say yes. Okay. Now the go to project analysis options. You can see the default demand pattern is pet1. So wherever there is a demand, unless we specify a different pattern, it will use this consume pattern. Then um, go to project analysis options again and see no, not there. Go to times. So total duration 24 hours. So we went to time in data, total duration 24 hours, hydraulic time step 1 hour. So every 1 hour calculate the uh, uh, the hydraulics. So the rest we can leave it as it is and run it again. There is an error. Let's say negative pressure at 6 hours. Okay. Now this is interesting because what happens is now there is so much demand here that this pipe cannot deliver that demand. So one of the uh, drawbacks of many network design software is that they assume that any demand can be delivered. So if we say 40 or 60 liters per second, it assumes it can be delivered and then calculates the pressure. So what will happen is then your uh, your pressure here will become negative. You can see this because this happens at 6 o'clock, they said. So go to 6, you can see there is a negative pressure. So this is an unrealistic situation. A network will not work like that, but the software will show it like that because the software assumes that the demand can be delivered. So what we are going to do is to increase the pipe a little bit. Instead of 200 millimeter diameter, let's put a 300 millimeter diameter pipe. So that should make it possible to deliver this water. Let's see the peak times, 6 o'clock. Yeah, now it's nice. So now what I want you to do is to go here and try to plot maybe the pressure. So you can see, now you can see a, a time varying pressure pattern because our demand is changing. So as a result, the pressure is also changing in the network. So minimum pressure is about, you can see 16 meters and the maximum is about 20 meters. Yeah. So that is it for this video.